Hi there. Let us rank the following labeled hydrogen atoms in the order of decreasing acidity, which means we are going to start from the one with the lowest pKa to the one with the highest pKa. Okay? And of course, you learned about the factors that contribute to the stability of the conjugate base using the acronym ARIO, where A stands for what? Atom. I guess you got it right. R stands for what? And I and O. Of course, the one that you never learned is the solvation effect. How we can use a solvent to stabilize the conjugate base. For example, if we use an ethoxide and compare it to when we use a tert butoxide. So if we use a solvent like water to stabilize this charge, then what's going to happen is that water will easily access the portions of the ethoxide due to less steric effect. So then it stabilizes the charge better. Or if we are to use a solvent, let's say, to stabilize the tert butoxide, then the problem is these methyl groups, they're not going to allow water to give a favorable stability, in other words, to penetrate and be able to stabilize the charge. So only a small amount of the water will be able to have access to this other portion. So it's going to be less stabilized by the solvent. And that's why the pKa of tert butanol is 18 compared to the pKa of ethanol, which is 16. So that's more acidic because it is slightly more stabilized compared to that of tert butanol. Of course, you learned about this, and I've given you the information in the notes. Please refer to them. If you have any questions, let me know. But what I want to clarify are a few things that I want you to take seriously because we're going to review them throughout the semester. The pKa of a carboxylic acid is roughly 5. Keep that in mind. The pKa of a diketon, in this case where you have a carbon flanked by diketon, the pKa of any of those protons is 9. The pKa for phenol is roughly 10. The pKa for alcohols, aldehydes, and ketones, the pKa we are going to assume is between 16 to 19. That's all I want you to remember. Between 16 all the way to 19. These functional groups, keep that in mind. Then, of course, the pKa for sp hybridized carbon, the one for ammonia, of course, you have used this when doing reactions involving alkynes, where this pKa is 38. The one for sp2, that proton has a pKa of 44. The one for sp3 has a pKa of 50, which is of course due to the effect of the orbital, the s being closest to the nucleus. So the more the s character, like in this case 50% s character, 50% p character. So the 50% s character means it's much closer to the nucleus. The nucleus is positively charged. So the nucleus can help to stabilize the conjugate base. Okay? Now let us try to answer this question. Rank these hydrogen atoms in the order of decreasing acidity. Based on what we just said, we can assign the pKa values. So let us start from A, that is sp2. So the pKa is 44. This is sp3, the pKa is 50. And here, an alcohol, the pKa is between 16 to 19. But there's also here this compound which is a ketone, where we say the pKa is also between 16 and 19. So between C and D, we need something else to help us tell the difference. That's where the induction effect comes in. Induction effect is when you have a more electronegative atom that can help to stabilize the conjugate base better. For example, if you have an alcohol like ethanol, pKa is 16, but if you replace these hydrogens with chlorine, the pKa is 12, because these compounds are more electronegative. So therefore, when you have the conjugate base, they are able to stabilize the charge by induction. So due to induction effect, they are able to stabilize the charge, so they lower the pKa. So that means this pKa is roughly, we can just estimate, could be like 11, and this is between 16 to 19. So therefore, the lowest is Hc. So we're going to start with Hc being the highest, the one with the highest acidity. So that's greater than Hd, which is greater than Ha, which is greater than Hb. So from the most acidic to the least acidic. Thank you for watching. Have a good one.